Good morning. Today we will study about assignment of R and S configurations, E and Z nomenclature. Okay, how R configuration is assigned. For example, optical isomers, geometrical isomers. How R configuration is assigned, how S configuration is assigned. There is a rule, there is a priority rule, sequence rule given by Cahn-Ingold-Prelog sequence rule or priority rule. According to using this rule, using these rules, three simple rules, 1, 2, 3 simple rules, the configuration is assigned. RS configuration is assigned, E and Z configuration is assigned. Okay, now what are the rules? Let us understand the three rules. First rule says, higher the atomic number, higher the priority. Okay, if the atomic number is higher, then it will be given the highest priority. If you look at the example, for example, this is an asymmetric carbon atom and connected to 4 different groups. What is the valency of carbon? Carbon valency is 4. Therefore, there are 4 different groups attached to 4 different atoms attached to this carbon atom. It is an asymmetric carbon atom. This configuration, for example, this is tetrahedral. Okay, now tetrahedral, carbon is tetrahedral. So this iodine, chlorine, bromine, and this is hydrogen away from you. This is 2 groups are away from you, 2 groups towards you. I and Cl are towards you. Now I projection on a 2D paper. Now it becomes what? It will become a Fisher projection formula. This representation of 3D structure on 2D is called Fisher projection formula. Now let us apply this rule and assign the R configuration or S configuration. For example, iodine, this is having the highest atomic number, first priority is given. So next to bromine, second priority is given, and chlorine, third is given. Now the arrow, now you draw arrow. Okay, if the arrow moves in right hand side, then in Latin, R means rectus. In Latin, R is rectus. It means right. The arrow, if your eye moves in the clockwise direction, if your eye or the arrow moves in the clockwise direction, then it is called R. Okay, that is R configuration. And for example, here, if you look at here, this is oxygen, 8 atomic number. This is carbon, atomic number is 6, and this is atomic number 1. What is the atomic number of deuterium? 1. What is the atomic number of? Now there is a confusion. Which one is given top priority? For given atomic number, the isotope with the greater atomic weight, atomic weight is given preference. Therefore, this is 3 and this is 4. Because the atomic weight is for the same atomic number, D is the mass number, atomic mass is 2, this is atomic mass is 1, therefore this is given priority. Now the arrow, see 1, 2, 3, the arrow goes in anti-clockwise direction. This is in anti-clockwise direction, that is S sinister left, it moves in the left direction, the arrow moves in the right direction. Therefore S means sinister in Latin, it is in English it means left. Okay, now we have assigned R configuration, S configuration using the priority rule, using the sequence rule 1. Okay, now similarly we can also using the same rule, using the same Cahn-Ingold-Prelog priority rules, we can assign Z isomer, E geometric isomer. For example, this cannot be called cis or trans isomer. If 2 CH3 groups are on same side, if 2 CH3 groups are on same side, cis isomer. If 2 CH3 groups are on opposite side, trans isomer. But here, all the groups are different. All the 4 groups are different. Now let us assign the priority sequence rule first. for first carbon. Okay, this is the highest atomic number, so 1, and this is given atomic number less, so preference 2, and here this is for this carbon, you consider the 2 carbons separately. Okay, this carbon separately, carbon 2, and this is 1 and this is 2. See, you see the high priority groups, the high priority groups are on the same side, or low priority groups are on the same side. Therefore, Z means, in German, Z means zusammen. Zusammen means same set, Z. For example, you see Z, S. So it is similar. Cis, same set, or therefore Z isomer. Okay. Now look at this isomer. Okay, I have interchanged. This group is interchanged. Now this is 1, this is 2, and this is 1 and 2. Here you see the highest priority groups. The highest priority groups on each carbon are on opposite side. Therefore, E means opposite. In German, it means entgegen. Okay. Therefore, E, this is assigned E nomenclature. Okay. This is Z nomenclature and E nomenclature. Okay. Now let us look at the second sequence rule. What is the second sequence rule? Look at the next atom connected. If the priority is not decided, if we are not able to decide the priority, for example, you will see, then we need to look at the next atom connected. For example, you see this example. In this example, OH, and this is oxygen is having greater atomic number, therefore 1. And here both are carbon. Now see, both are carbon. These two groups both are carbon, but carbon is connected to another carbon. Here carbon is connected to hydrogen. Therefore, look at the next atom. Now next atom is carbon. So it is more atomic number, same rule. Therefore, this is given the highest priority 2. Next higher priority 2, and next this. Now if you look at the arrow 1, 2, 3, the arrow moves in clockwise direction, therefore it is right direction, then it is R configuration. Similarly, you look at a different example. This is 1, okay, this is 1, and this is carbon is connected to carbon, this is carbon is connected to oxygen of greater atomic number, therefore this is given higher priority than this 2, 3. Now 1, 2, 3, arrow moves in this direction, therefore this is R, this is again R clockwise, okay, clockwise, therefore R configuration. Okay, now look at the third rule. Third rule is not often used. These rules are often used to remember these two rules with examples. Once you know the examples, you will understand. Okay, now double bond, according to the sequence rule 3, priority rule 3, double bond is duplicated, triple bond is triplicated to assign the priority. Okay, for example, how it is duplicated, I have shown you C double bond. Okay, C double bond, therefore carbon is connected to oxygen, and carbon is connected to oxygen, and 2 duplicated, therefore carbon is another bond, therefore another oxygen, and oxygen is connected to 2 carbon, oxygen is connected to 2 carbon, this is 1 carbon, and therefore oxygen is connected to, this oxygen is connected to 2 carbon, therefore what you will get, one right, oxygen is 1 carbon, another carbon, okay, this is 1 carbon and another carbon. Similarly, this oxygen is connected to one carbon, okay, correct. Next, C triple bond N, it is triplicated, therefore carbon nitrogen, carbon is connected to nitrogen, carbon is connected to first thing. And nitrogen, look at each nitrogen is connected to 3 carbon, therefore 1 carbon, and 1 carbon. Okay, so according to the sequence rule, priority rule 3, the double bond is duplicated and triple bond is triplicated. Okay, now there are three steps to assign the configuration. There are some cases, for example, it will be confusing. These rules are very much essential to assign the configuration. Please remember these rules. I have given, it is not given in the textbook especially. See, you look at that, in this case, see, this is iodine and this is chlorine and this is bromine, and iodine is away from you. Okay, so sorry, hydrogen is away from you. So you visualize the molecule. Please, you visualize or rotate the molecule so that the lowest priority group is away from you. So away from you. This is lowest priority group is hydrogen. This is 1, 2, 3. Hydrogen is the lowest priority group, is away from you. Then you rotate. Otherwise, you will commit mistake. So 1, 2, 3. So R configuration. Similarly, here 1, 2, 3. Hydrogen is away from you. Okay, remember, always keep hydrogen is away from you. 1, 2, 3, and this rotates in left direction. Yes. Okay. Right. Now let us consider another example. Very, very important example. Secondary butyl chloride. See this. These two hydrogen. This means dark rectangle. Dark rectangle means hydrogen, thumb and chlorine are towards you, and these two groups are, for example, you see, are away from you. CH3. But what I said is, the lowest priority group is towards you. It should not be the case. It should be away from you. Therefore, you just rotate. See, 180 degree. I am just rotating the molecule. Not I am converting. This isomer is different. This isomer is different. So just I am rotating. Now you see this hydrogen in the left hand side. I am just rotating the molecule. Just the same molecule only. Now you see hydrogen is on the right hand side. Chlorine on the left hand side. Now hydrogen is away from you. See, hydrogen is away from you. The thumb is your hydrogen actually. So it is away from you, and this is towards you. This group is towards you. This and this towards you. Therefore, if you assign the priority, 1 here, 1, 2, 3, then this is R configuration. This is not R configuration. Remember, this is 1, 2, 3. So S configuration. This is secondary butyl. This is S configuration. It will be confusing. So remember, the lowest priority group is always away from you. Next, single interchange. This is a question asked in IIT JAM or in JEE NEET. They will also ask. For example, here, if I do one interchange, CL, one interchange, S will become R. Remember, if I do one interchange, CL goes here and C2H5 goes here, and if you look at the priority rule and the hand movement, the arrow movement, it will be S, this will be R. So on single interchange, S becomes R becomes S, vice versa. Okay. Whereas on double interchange, if you double interchange, again you change this group to this. Okay, you will get S will become S. On double interchange, S will become S, R will become R. Okay, so there will be no change in the configuration. So please remember these three rules proposed by Cahn-Ingold-Prelog sequence rule. These are very, very useful for R and S configuration assignment and also E and Z assignment. Thank you for watching.